Our project is focused on building a new generation of electronic devices based on organic molecules. Organic electronic materials have the potential to really transform the way that we make and use consumer electronics. From flexible display screens to solar cells, which are just so light that they could be incorporated into our clothing or even used to coat the wings of aircraft to provide power. These devices are composed of extremely thin layers of materials, often just a few billionths of a meter thick. And they're created by actually organizing molecules at an atomic level. The reason why the large-scale computing grant is so important to this work is really very simple. I mean, we can't see atoms. And so basically, even with our most sophisticated experimental techniques, we can't determine precisely how molecules interact and assemble at these very tiny scales. So what we can do is that we can use the high-performance computing capability at Gabi to be able to simulate the way that these molecules move and interact and essentially assemble into the materials which form these devices that you can see behind me. So the amazing thing about organic materials, as opposed to silicon and other things that we currently build electronics from, is that they can be processed in many very simple ways. They can be condensed onto the surfaces, or they can be dissolved in a solution and simply sprayed on, for example, by an inkjet printer. So you could sort of imagine printing a new display or a new solar cell. Now, this is already possible in some cases, but these layers are so incredibly thin that what we know is that slight differences in the way that the molecules hit the surface will change the properties of the final device. We know the materials differ, but we don't know how or why they differ in the way that they do. So the key questions that we're wanting to address is really, why do devices have different properties depending upon the way that they're manufactured? And can we predict the behavior of specific molecules in order to be able to make better and more reliable devices? The way we're going to do this is to actually use the grant to simulate or to mimic in simulations how these devices are actually formed. Literally by allowing molecules to condense on particular surfaces, or, for example, dissolving mixtures of molecules in a solvent and allowing that solvent to evaporate during a simulation. Now, in both cases, this requires us calculating interactions between millions of atoms, moving all of those atoms, and then repeating that process billions of times, in a sense, to make a very detailed atomic movie of exactly how these devices form. Now, such calculations are enormous, and they're really only possible if we have access to the types of facilities which Gabi and NCI are able to provide.